Before I start my session, Utthunga as a team would like to thank OPC Foundation for giving an opportunity and the platform to share our OPC experience with the OPC community and the audience. So the session that we are going to talk about is that about moving the device data, how you can take the device data all the way from the automation layer below and move all the way to the cloud and build the digital twin replica of these devices in the OT domain as well as in the IT domain. Okay. Now, before I move ahead, let me introduce my team. This is a team who worked on this paper, but for the sake of simplicity, Amugam and I'll be speaking mainly on this session. So, what is the problem statement we are trying to address with the help of this paper, right? This is one of the common problem, that today, as the IT and OT domains are converging, industry is facing a lot of challenges to move the data from OT to the IT. Now, what are these challenges, right? One of the biggest challenge they have is their current brownfield setup, right? They already have a big brownfield setup which was built over a period of time. And because it was built over a period of time, they have a numerous devices that are coming from different generation, speaking different protocols. And because they are speaking different protocols, this data is fragmented in the automation layer, right? And as they start moving the data from the below automation layers to the higher levels, it starts converting from one protocol to another protocol. And as that happens, the data is getting distorted or the data is getting lost also, right? And that is causing them a problem. And the last problem is that because they have such a heterogeneous setup, the running cost of the plant becomes very heavy because they have to have a separate support staff to manage these protocols. And now they want to clean this up and start having fewer protocols and also have the ability to move this data to cloud. And when we start when we start suggesting solution for this, we always suggest a solution which is based on OPCA framework. Okay. So what we suggest them or what we recommend that is when we are trying to move towards OPCA based solution, the first thing you should do is try to convert the OPCA data, the data from the source to OPCA at the source level or the lowest possible automation stack level. So with the help of different converter technology or different technologies, what you can do is you can convert the data, non-OPCA data to the OPCA data at the source. So if it's a Modbus data, you can use OPCA server, OPCA Modbus server to convert from Modbus to OPCA. If it's a classic OPCA servers data, you can use OPC wrappers or proxies to take it from the classic to the OPC UA format. And once you start having the data in the OPC UA format, then you can also start using the information model, right? I can start adding the information model to bring the metadata, to add the types to the existing OPC UA data. And of course, once you have start using OPCA framework, then you can also use the OPCA standard security to bring authorization, encryption, and make sure that there are no security compromises, right? And that's the crux of this session. What we are trying to present is, what we are trying to present is a session where we are going to show how you can build a digital twin replica of these devices in the OT domain using client-server technology and information model, as well as how you can bring the digital twin replica of these devices into the cloud using OPCA PubSub data and information capability of ADX. Okay. Now, this is where I'll hand over this session to my colleague Amugam, who is an OT expert, and he will take care of the further slides. Amugam, over to you.
Yeah, thanks, Praveen, for the introduction. So here we are seeing that a typical parameter and its value from the instrument. So today we took that example of level transmitter and its value from the instrument which is using the hard communication protocol. So let us see how this value are mapped from sensor to the OPCWay server using the PDM information model. So as you see, I took an example parameters like identification informations, nameplate info, diagnosis status, and some of the process values including engineering unit and ranges. So on the third table, which mentions some of the configuration parameters. So all these items which how we can port it to an information model. So let us see how these parameters seen above have been mapped to the PDM information model. Before that, I'll provide quick intro about what is PDM. So PDM is an information model, talks about mostly on this process automation devices. So PIDM is a common information model which provides the device data regardless of protocol, type, or manufacturer. So each device or transmitter in the field will be represented by that PIDM type under the information model. So the uniqueness of the PIDM type nodes has a semantic ID which is universally accepted, which are referred from IEC Common Data Dictionary. So also this PIDM includes all that informations like nameplate info, device diagnostic status with alarm informations, and process signals, critical parameters from the instrument, which includes ranges, unit values, and signal tags. So also this information model shows the configuration parameter under the parameter set. So moving to that, this is a typical information model mapping of an instrument where you can see this is a sample instrument which shows for a pressure transmitter, which maps with an PIDM type. Under that, you have a nameplate info and the signals which are classified under the signal sets of critical process variables. So which includes, as I mentioned, all the ranges and engineering units and instrument ranges. So each signal again mapped to their own semantic ID, which under that has dictionary entry. Apart from that, so this information model also includes the parameter sets, which basically comes from that OPC UA device information model. So with the above information model, so as you can see that a screenshot of an OPC client, which depicts that PIDM information model comes out of our product UDX suite. So which has an accurate mapping of the above device properties or values, which are getting a real-time data of the device using HOT protocol. So our UDX suite OPC server can create an accurate representation of these devices in the OPC way address space. So any OPC client connect to this our OPC server and get the data as well as property of the device shows as a digital twin of the device in its own user interface. So the above diagram shows the parameter set for that above device coming out from that our product UDX suite. So please note that parameter names and the values which you are seeing in that screenshot, which is the exact replica of your device properties and values. So with these multiple proofs, it can be detected that a digital twin of a field device described in the previous was accurately modeled in OPC server. So with the help of OPC PIDM information model. So the next section explains how this data, if converted to OPC web, pops up and can be easily processed by any subscriber. So from here, I hand over it to Praveen, who will take up that next section.
Okay, so can you guys hear me clearly now again? Can you hear me?
Yes, we hear you fine.
Okay, okay. Okay, so thanks, Amugam, for the session. So as you saw in the session shared by done by Amugam, with the help of OPCUA client server and PID information model, you can actually create the replicas of below devices, and you can see the properties connected via references. And one thing to note there is, all the types that were shared by PID information model or OPCUA server were dynamically taken by OPCUA client, right? I mean, as you start building new types, the UA client doesn't have to do anything else. It has a built-in ability to see that types, and as we can see that the digital range replica in OT domain was accomplished with the help of client-server communication and PIDM, right? Now, let's see how this can be done in the IT space. So before that, let me introduce PubSub. OPCA PubSub actually stands for OPCA Publisher Subscriber Model. And now this is a protocol which was built by Foundation, to take the data from the OT domain and start moving data towards cloud, right? I mean, if you look at most of the cloud players today, they have a built-in ability to take a data over messaging protocols like MQTT or AMQP. And we are leveraging that, Foundation leverage that, and they built OPC PubSub model in such a way that it can work over this messaging protocol like MQTT or AMQP. Now, as the name suggests, in case of publisher subscriber communication, publishes, which is closely equivalent to what server does it, publishes data once to the broker, and once the data is available on the broker, the subscribers can pick it up from there. And because publishing is happening only one and the subscriber picking up, this becomes a much more efficient communication. And once you have the broker-based communication, it becomes cloud-friendly natively. And because this PubSub communication has the ability to get the OT data from the from the TCP/IP format to the PubSub format and put it on a broker. Cloud players have already started adopting it, right? And Azure already has this built-in ability to take this PubSub data and understand it natively for further processing, and that's what Azure IoT operation does it, right? So let me go to the next page here. So now what you see on the screen is a typical OPC UA PubSub structure, which is taken from the TCP/IP format sometime back, which Amugam was showing in a client-server format. You can see the same data coming here in the PubSub format. You have a asset ID, you have a revision counter, you have hardware software revision. So you can see that almost all data that was exported in the OPC client server format is available here in a PubSub format. Now the question comes, how do you convert the data from TCP/IP format to the PubSub format? And for that, there are multiple products available in the market, and we are using our own product, which is called as UOPC Data Bridge, Utthunga's own product, to do the conversion from the TCP/IP to the PubSub. And now one more advantage that we have to discuss here is that the screenshot that you see on is taken from the MQTT client. It's a Mosquito client, which is MQTT client. So what happens is once the data is converted to a PubSub format, because it's a MQTT packet, you can actually use any MQTT client to take this data and not necessarily only have a UA client. So that is another advantage you get it once the data comes in PubSub format, because they are JSON packets or MQTT, any MQTT client can actually read this data. Now, what you see on the screen next is the screenshot taken from Azure Event Hub. So this is what some time back I was talking about. Azure Event Hub already has a built-in ability to understand the PubSub data. And here what you see is PubSub data as well as PubSub metadata, right? So what's the difference? The PubSub data is the real-time values, which we have taken it from the below UDDX server, which Amugam was demoing it some time back, and converted to a PubSub format, which has a device data. And the metadata for the same data shows the semantics of the data, which you can use to interpret the data more accurately. And in the Azure Event Hub, you can get the data as well as metadata. So here you can conclude that, in the with the help of PubSub format, you can transmute all the device data from the client server in the PubSub format into Azure, right? Now, what is lagging is the information model. So let's understand that, or let's see how to get that. And that's where OPCUA Cloud Library comes in picture. So OPCUA Cloud Library is an initiative taken by Foundation some time back to make OPC information model accessible from the cloud. So basically, it's a cloud library which is residing in the cloud, and it gives you a REST API interfaces to fetch all these already built information model from the this cloud into your respective solution in the cloud, right? And Azure also is doing that. Azure already has given a built-in support to fetch this information model from the cloud library using queries. And the below screenshot is showing you that. In the below screenshot, what we've done is we have run a query in the ADX to pick up a PID information model. And you can see all the PID information model types are shown below. So now here you can see that, you already have the PubSub data, you got the PubSub metadata, and you also have the information model, right? And so what we are building this complete architecture here, where what happened is you got the UDDX suite data coming from lower automation stacks used in the client server format and PID information model. Once the data reach at the entrance of the cloud or at the periphery of cloud, we converted the data from the TCP/IP format into the PubSub format. Now, once the data is in the PubSub format, Azure can understand it. Their components can understand. And we were also able to fetch the PID information model from the cloud library into the ADX. Now, with the combination of these three, you can actually run different queries in ADX. You can run different queries and write different logic to build assets and build this, different dashboards in the ADX to make the best use of this data. And with that, you can actually conclude that you can actually make a digital twin components built inside the Azure with the help of PubSub data and information model fetched from the cloud library, right? So in summary, what we have shown till now is in the OT space, you can use client server and peer information model, whereas in IT space, you can use the PubSub format plus the cloud library. Now, what's the advantage you get it? I mean, when we recommend or when we suggest OPC to use OPC UA ecosystem end to end, right? These are the advantages you get it for the end customer, right? Now, because the data is coming in the OPC UA format, all the way from the below levels to the cloud level, you have a holistic data analysis view, right? Because you get a complete data without any distortion, plus you have the metadata and the context of a data, you can make a much more improved decisions, right? Because you are pretty sure the data is correct, you can make a much better data decisions. Plus, another advantage you get it is the data handling, right? I mean, because you have only one protocol data coming, the data cleaning is much more easier, data processing is easier, as well as the storage is easier. And because, again, the data is in the same format, the data interpretation becomes much more easier, right? And with the PubSub, you get the support of cloud, right? Now you can start using cloud to build your solution, manage your solution. And with the cloud, you can actually now run a distributed architecture where you can run your solution on different nodes, which are all taking the data from the incoming OT, from OT in the client server to PubSub, right? And once you have all this data, you can start building your data-driven models, right? Because once you start building AI ML models, they are all data-driven. They need a lot of data, and you can do that with the help of this OPC ecosystem. Now, the last and very critical point is what happens now is the end-to-end system is interoperable. Now we have, because you are using OPC all the way from the L1 layer to the cloud, the data is completely interoperable. All the systems are interoperable. You can get the data from the below to the cloud, and you can send back the data as well, which is the topic of discussion from some other day. But it's possible that you can make a decision in the Azure cloud based on the data and send the commands back to the OT system based on whatever is being decided, right? Let me summarize the session now. What we have discussed is, with the help of this case study, what we have demonstrated is we have demonstrated robust capabilities to build this digital twin in OT space. They build a digital twin in the cloud space, and where as and when required, we use a different communication model such as client server or PubSub, and use a appropriate information model. For example, in this case study, you are trying to use a period information model because the product that you are trying to was the device data. You are trying to get the device data to the cloud, but we had other use cases where we are trying to model something else. In that case, you can use other information model like IS95 or AAS, depending on your use case and your data. And once you have got all this thing, you can do improved data analysis, decision making. And basically what we've done is we have given all the necessary tools and information to the end organization, to the customers, to optimize their asset performance. And once they are optimizing the asset performance, obviously they are going to reduce the operational cost. And more importantly, they had taken a correct step and more informed step to start doing the digitalization journey, right? Now, so this is a summary. Now, let me just share one more slide and another exciting news. Actually, today we are also releasing a book on OPC UA from Utthunga. This book we are releasing today only, and it will be available on online platforms. This book is authored by Smita, our co-founder and MD in Europe, CP, another colleague of me, myself, and we have a guest author, Andreas from VDMA, doing a valuable contribution. The advantage of this book is written from a practical point of view. Almost everything that's written in this book is written from use case point of view, from customer point of view, trying to explain how a certain use cases could be addressed using different features of OPC UA, different characteristics of OPC UA. Okay. Yeah, so that's it. For any more information, if you want on this case study or any other information that you want from us, inquiries, you have any, you want any demos, you have any feedback for us on this session or any suggestion, please feel free to write us at contact@utthunga.com. Yeah, Q&A. We are open for questions now.